Right. Now we watch. Just reading some videos, trying to keep me alive. Sometimes I feel bored also. What to do? Oh, I think I need AC. I cannot switch it off. My PC needs it. Beautiful babies. How do I look? Not so good. Okay. Oh, you made a mistake, baby. liking it. Let's Can I take some break? Maybe not. So my job is right now editing, and basically I'm editing a wedding right now. Sometimes I feel happy when I see footages and all. You can at least you can see people's emotions and everything. It taught me a lot. I think I don't know. It's just strange. hard work. Oh, she is beautiful. I spotted a lady in a crowd and she is charming. I think important people I really don't know if they are. Should I keep them? I guess so. I feel really happy when I see a woman appreciating another woman. Like, you know, I don't know, this feeling is something like I really appreciate. Cause I don't know, maybe I'm not, maybe my surrounding is not that good, or is that usually happened everywhere that girls are not usually stick together, I guess. Nowadays, at least, I guess. But whenever I see that, I love it. I like that. I wanted this thing to be normal. Am I wrong? Maybe, or maybe I'm not. It's just my experience that I'm gonna share it. That I'm sharing it. I'm so sorry about my English. It's not good, but still I'm talking in English because I wanted to learn it. And where should I practice this? So here I am talking with myself. I think she's the groom's sister, and I can see that she's very happy. You can see it in her eyes, like she's happy for her brother. I guess. I mean, definitely she. Why she would not? Sisters love. When I see this kind of gathering, sometimes I miss my family. I think cameraman is like that girl. Hmm. So it happens, being an editor, you can see the footages and also you understand the cameraman just because you understand the shot and also I don't know should I share this or not, but sometimes it's funny. And it happens, usually guys, like they tend to be like or have crush on some girls on the wedding or like gathering and everything, and they tend to like shoot them like I mean when you see that when you see the shots you understand that thing. I mean you can definitely. I'm an editor, so I know that. I'm feeling weird. Why, because I'm talking out loud about my thoughts that usually I think in my head while editing. To hear it, it's little sounds silly to me, but I think I'm having fun right now. Happy family. Ouch. My back hurts. It's been 30 minutes now, okay. What to do? What to do? Let's take a break for 5 minutes, maybe. Yeah, I should. I don't know what to do. What should I do? I'm taking break, but I don't know what should I do. Okay. Oh, this is nice. Whenever I think I should do that often. Whenever I get bored while editing, I should switch to the study. And whenever I feel stuck in study, I should go back to the editing. That's how I can manage both things, right? Ah, yeah, I should. But which one is this? This is not my book that I was reading. Oh, this one is also not. Ha! I don't want to lose it. Oh, yeah, this one it is. So, last time, what I was reading was SI unit, and I think I reached that part. Uncertainty in measurement. Nope. Wait, volume. Derived SI unit. I was learning derived SI unit, so I have learned volume, and this one also density. I think I was yeah. Yep. Let's read density. Ha. Density is defined as amount of mass in a unit volume of a substance. So density is defined as the amount of mass in the unit volume of substance. So density is equal to mass on volume. Yeah. The densities of solid and liquid are commonly expressed in either gram per cubic centimeter, gram per cubic centimeter, or gram per milliliter. Okay, for the solid, you can say gram cubic per centimeter, and for liquid, you can say gram per milliliter. Hmm. Density of some common substances are listed in this table. Okay, in this, no coincidence that the density of water is 1.00 gram per milliliter. So everybody should remember that the water density at room temperature or maybe around 25 degrees Celsius is 1.00 gram per milliliter. Yes, 1.00 gram per minute. And about air density is 0.001. Yes, gram per cubic meter. Cubic centimeter, oh sorry. Yeah. So the term density and weight are sometimes confused. A person who says that iron weighs more than air generally means that iron has a higher density than air. 1 kg of air has the same mass as 1 kg of iron, but the iron occupied a smaller volume, thereby giving it a higher density. Yes. If we combine two liquids that do not mix, the less dense liquid will float on the denser liquid. Yeah, definitely. This is general. I think everybody knows that. Okay, so some common substances and their densities like air, as I told you, 0.001 gram cubic centimeter, and balsa wood. Well, I don't know what is balsa wood, but I understand it's a type of wood. Balsa wood has a density of 0.16 gram cubic per centimeter. So this gram cubic per centimeter will be the stagnant for all this thing. Okay. So ethanol 0.79, water 1, ethylene glycol 1.09, table sugar 1.59, table salt 2.16, iron 6.9. Oh, it's denser. Gold is even more denser. Gold has a density of 19.32 gram per cubic centimeter. Uh-huh. And we have some sample exercise like determine density and using density to determine density and using density to determine volume or a mass. Okay. First question is calculate the density of mercury if 1.00 into 10 square gram occupied a volume of 7.36 centi cubic meters. Okay. So basically, density is equal to mass upon volume. Calculate the density of mercury if volume of 7.36 centimeter cubic and what was the mass? 1.00 into 10 cubic. So, 10 to the power 2 means what was it? Centigram. Yeah, called centi. And then you have to do the math. Then it comes 13.6 gram. Ha! Math is the requirement of learning chemistry and further higher study in chemistry. But I feel lazy for doing math and calculation. Oh, yeah, but I understand that. I just have to calculate this, but solution is already given here, so I'm not doing it right now. But I'm gonna revise this later on, so that's why. Solving equation 1.3 for volume and then using the given mass and density. Volume, mass, and density is equal to this. Practice. Chemistry put to work. Chemistry in the news. Okay. Because chemistry is so central to our lives, reports on matters of chemical significance appears in news nearly every day. Okay. Some reports tell of breakthroughs in the development of new pharmaceuticals, material and processes. Other deal with energy, environmental and public safety issues. Are you study chemistry? Are you study chemistry? Definitely I'm studying chemistry. You will develop the skill to better understand the importance of chemistry in your life. Here are summaries of few recent stories in which chemistry play a role. So I don't know how recent they're talking about, because this book is definitely a little old. Biofuels reality check, okay? With the Energy Policy Act of 2005, the US Congress gave a big push to fuel derived from biomass, plants or algae based fuel, as a renewable alternative to gasoline, okay? The 2025 Act was followed by the Energy Independence and Security Act of 2027. No, sorry, 2007. 27 now, 27 crazy. Which required that 9 billion gallon of renewable fuel be used in gasoline in 2008, 11.1 billion gallon in 2009, and 36 billion gallon by 2022. Oh, it's pretty recent. The United States recently consumed about 140 billion gallon of gasoline per year. Okay. Ethanol derived from corn currently dominated the alternative, with 40% of gasoline now containing some ethanol. A blend of 10% ethanol and 90% gasoline called E10. Oh, in the most common blend because it can be used in virtually all vehicle. Blend of 85% ethanol and 15% gasoline called E85 are also available but can be used only with specially modified engine. Yeah, definitely. But I think it will be gonna happen very soon that uh, advanced as we are growing right now. Recently, I think that's just my opinion. It will gonna be opposite. Like E85, people will usually use it. It will be gonna normalize very soon. I think so. Because scientists know that they cannot rely on uh, petroleum resources for so long. So definitely, scientists are scientists. They're gonna build something new. However, using a food crop to produce transportation fuel may not be the best long-term solution for the energy problem. Okay. In 2006, researchers at the University of Minnesota, Minnesota, okay, I'm so sorry about my pronunciation, calculated that even dedicating all US corn and soybean production to biofuel would meet only 12% of gasoline and 6% of diesel demand. Yeah, definitely. Like, we'll have to find the alternative. Cannot use this is not sustainable for so long. The conversion of a much wider range of plant material using a much greater fraction of available plant matter into fuels will be necessary to improve this number substantially. Yes, that's how it's pronounced, I guess. Because the most abundant plant material Cellulose does not readily convert to ethanol. A great deal of research will be needed to solve all challenging problems. Meanwhile, it is worth reflecting that a 3% improvement in vehicle fuel efficiency would displace more gasoline use than the entire 2026 US ethanol production. An alternative to ethanol relies on coaxium microorganisms to produce molecules that can be used as a fuel. In 2029, ExxonMobil ExxonMobil Research and Engine Company partnered with a startup company, Synthetic Genomics, to find strain of photosynthetic algae that will efficiently produce oil and hydrocarbon from sunlight and carbon dioxide. Advance in solar energy. In the 1970s, at the height of the oil crisis, there was a burst of research on renewable energy. Okay, in the 1970s, at the height of the oil crisis, there was a burst of research on renewable energy, including solar energy. After the oil crisis, okay, including solar energy. After the oil crisis passed, a gasoline was once again cheap and readily available. Solar energy research was less of a priority. With the more recent increase in gasoline price and a greater realization that the burning of fossil fuel contribute to global warming, solar energy research is again in vogue. The amount of solar radiation reaching Earth every day is enormous, and if we could harness it efficiently, our energy needs could be easily met. Solar panel like those solar panel are about 10% efficient in converting light directly into electricity. 10% efficient, okay. I think today only I have I don't think I have read it, but I have seen it in a YouTube video that they were saying we reached, I think, max 42% efficient. Yeah, we can convert the solar energy into usable energy. Solar energy, okay. But you know what? What interesting is that how chlorophyll managed to, like, convert 100% energy into, I mean, how plants convert the energy into chlorophyll, like those green pigments. Their efficiency is 100% definitely. So the video was about definitely about that thing, how it happens, how we are not able to do this. But I think it's in a progressive phase. People are still researching about it. Uncertainty in measurement. Okay. Two kinds of number are encountered in scientific work. Exact number, those whose values are known exactly, and inexact number, those whose value have some uncertainty. Yeah, most of the exact numbers we will encounter in this book have defined values. Okay, for example, there are exactly 12 eggs in one dozen, exactly 1000 gram in 1 kilogram, and exactly 2.54 centimeter in 1 inch. 2.54 centimeter in 1 inch. Remember that. The number 1 in any conversion factor, such as 1 meter is equal to 10 centimeter or 1 kg is equal to 2.2046 lbs, lb is an exact number. Exact number can also result from counting objects. For example, we can count the exact number of marbles in a jar or the exact number of people in a classroom. Numbers obtained by measurement are always inexact. Equipment used to measure quantities always has inherent limitation, equipment errors, and these are difference in how different people make the same measurement. Human error, basically, we're talking about the human errors. Also, there's equipment error that we just read. Suppose 10 students with 10 balance are the determine the mass of same time. The 10, how can we capture solar energy for use when the sun is not shining? One potential answer is to store the energy in chemical bond. Um, is something wrong? Is it? 20 and 21, yeah, there's nothing wrong. How can we capture solar energy for use when the sun is not shining? That's a question. You cannot, I guess. One potential answer is to store the energy in chemical bonds. One promising new material, first reported in 2008, is a cobalt containing compound that can convert water into oxygen with sunlight. Okay. Hydrogen can also be generated in sunlight from water but using a different compound to facilitate the reaction. Electricity can then be produced by combining the hydrogen and oxygen in a fuel. Huh. I'm thirsty. Just give me a minute. Coming back soon. This was translated to models of encompassing one combined activity that is essential to form bacterial cell. Researchers have synthesized an encompassing along with the CO group has been covered to the CH2 group. And modification increased the compound binding affinity cell wall of encompassing resistant bacteria, making the analog 100 times more active than encompassing agent of encompassing resistant bacteria. People through chemistry. Strong. Precision and accuracy. The terms precision and accuracy are often used in discussing the uncertain, uncertainties of measured value. Precision is a measure of how closely individual measurements agree with one another. Accuracy refers to how closely individual measures agree with the correct or true value. The dart analogy illustrates that difference between these two concepts. Good accuracy, good precision. Okay. Pure accuracy, poor precision. Pure accuracy, good accuracy, poor precision. Oh, precision and accuracy. What do you think about precision and accuracy? So let's read it again. The term precision and accuracy are often used in discussing the uncertainties of measured values. So discussed uncertainty of measured value, we use precision and accuracy. Precision is a measure of how closely individual measurements agree with one another. Precision is a measure of how closely individual measurement agree with one another. Okay, it's like it should be like that kind of referencing that people should follow. Okay, accuracy refers to how closely individual measurement agree with the correct or true value. Huh, I'm confused now with the dart analogy. Okay, the laboratory, we often perform several trials of experiment and average the result. The precision of the measurement is often expressed in terms of standard deviation. Okay, which reflects how much the individual measurement differs from the average. We gain confidence in our measurement if we obtain nearly the same value each time. Yeah, definitely. This is the standard deviation in small. Okay. However, the precise measurement can be inaccurate. For example, if a very sensitive balance is poorly calibrated, considered as a higher, they will be inaccurate even if they are precise. Okay. So, uh, if I have taken three readings and all those three readings comes around the same numbers, let's suppose 6. The first reading should come 6.1, maybe the second 6.2, the again 6.1, the third one. So it's like it's more likely to precise, right? Like, okay, I just